Model deployment is one of the most difficult processes of gaining value from machine learning. It requires coordination with data scientists, IT teams, software developers, and business professionals to ensure the model works reliably in the organization's production environment. Understanding this, we have come up with this tutorial on model deployment using Flask. So Flask is basically a micro web application framework written in Python, and it reduces development time and allows programmers to build faster and smarter. So in this, we will see how to do model deployment with this amazing web application framework called as Flask. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below.
So as all of you know, model deployment is the application of a model which you're making, right? Your job actually doesn't end when you have built the model. Building the model is one part of the entire data modeling exercise, wherein you have pre-processed the data, you have looked at the data, you have tried extracting out the insights which are available on the training data set, and based on those insights you have built a model. But the entire exercise really doesn't end by just building the model. The key is for deploying the model and looking at how your model really performs on an unseen data set. Now, what really is done as far as the model deployment is concerned, what we require is a graphical user interface, right? Now, this graphical user interface could be developed either using a platform like Java or .NET or any other platform which an organization already has, or it could be built by using the simple HTML pages. What I'll be showing you today are the HTML way of deployment, wherein I have built some basic HTML pages. So my idea was not to create some fancy stuff as far as those HTML pages are concerned. In fact, I have not used too much of the style sheets as well, in case if all of you are aware about how the HTML pages are being made. So the user inputs are taken through the graphical user interface, which is either built on the platform which is already available in the organization. As I said, either a Java or a .NET, or if the organization has deployed an enterprise-wide application like the SAP, then there are some inbuilt packages which are available which allows you to create those user interface. So ideally speaking, the key requirement for a model to be deployed is get those user interface, right? Why we require these user interfaces? Because through this interface is what we will take the user input. What are these user inputs? These user inputs are related to the features or the variables which were available in the training data set, and using those features we have built the model. Okay. So what you would have seen till now is there is a train, there is a test which you created, and we keep saying that test has to be exactly the same as a train. So using a test data set, we actually validate the model which you have built. Now, this graphical user interface will allow you to test the model on an unseen data set. Why we call it as an unseen data set? Because this is the data which a user would be entering it now. As an example, let's assume you have built a application to find the whether somebody would default on the loan or not. If I enter into the bank and I fill in the application saying that I want to apply for a loan, then while I am filling up the application, there are certain user inputs which I am providing. These user inputs are taken by the bank and they are given as an input to the model, which will tell me what is the probability that I as a user will default on the loan. Okay. So because I am the new user who is entering into the bank, I am the new user who is filling up the application form. That's why my data is known as an unseen data set. Whereas the test data on which you test the model is something which is already given it to you. It's a historical data, instance is already happened. Okay, so this is the fundamental difference. Now there are some other ways of also getting the user interface, getting the user information, which is like an auto-generated text, suggestion box, Facebook auto tag. I'm sure all of you would be aware about it, wherein by default Facebook allows you to mark the picture which you have liked it. So there is an auto tag which is by default, which is enabled. The idea was collect this auto tag or collect this information and use this as an input for predicting it or for giving a suggestion to a user saying you have tagged a photo of this kind. Okay, so either you have a user interface available to collect the user input for an unseen data set, or there are certain applications which are giving you some default options through which the data gets collected. The idea is to collect the data. Okay. Now, what are the key features of a model deployment architecture? First is the modularity. Now, why we say modularity is a key for a model deployment and specifically the pre-processing steps is because certain times the requirement is not just limited to doing a prediction from the data which is available. And I'm sure you would have seen it in the modules. Sometimes we just want to extract the insight which is available, right? So sometimes even the EDA or the pre-processing which we have done on the data set is important. So maybe the pre-processing which has been done on the trained data is something which we want to see on an unseen data set as well, right? This is one example wherein we say that modularity of the way the model has been created is very important. Reproducibility, which means my model deployment architecture which I'm creating should be backward and forward compatible. People from the software background would be able to appreciate the fact that what is a backward and forward compatibility. If there are some changes which have happened in the platform which we are using from a deployment perspective, then that platform should be compatible to the application which were deployed on the previous ones, right? Scalability. Now, this is probably a key requirement whenever we have the application being deployed on a at an enterprise level, and to ensure that the application which is deployed is scalable and it allows multiple users to be collecting the input or multiple user input to be collected through the interface. People have moved on to a deployment on a cloud, and what we also would be looking at is the cloud deployment, but what we'll be using is a demo version of that. Okay? Extensibility, which means if there are certain additional tasks which needs to be done, where do we have these additional tasks as far as the model development is concerned? So if let's assume if there is a new data set which is coming and this new data set talks about certain features which were not collected earlier and we are rebuilding the model taking those features into an account, then what we need to ensure is that the model which we have built and deployed should be extensible. It's not that we have to probably get into an exercise of doing a deployment from a scratch. Okay. The ability to test the variation between different model versions. So what I will not be able to show you right now is in terms of how do we compare different models which have been deployed, but I'll show you on the cloud platform that how this version control is managed, and whenever we have different models being available, every model has a life, right? So let's assume there is a model which was deployed in an organization for 3 months and maybe the model is not giving the required output. Sometimes we just go back and look at the previous version which was deployed. Now that previous version could be related to certain different pre-processing steps which were done or a different kind of features which were available on the data set. So the ability for the model deployment architecture to be able to manage these versions and provide an option to the organization to be able to test the model on different versions is okay. So if you really look at this in a complete way, then modularity, reproducibility, scalability, extensibility, and testing if all of you are from the software deployment background, you'll appreciate that most of these key features which I've just spoken about, these are the key requirement of any software which you deploy. And when we are actually deploying a model, it is in a very broad way, we can say it's like a deployment of a software, right? So that's why we are able to see that there is a strong relationship between the architecture requirement, what we see here for a model deployment, and when we compare it back to any software development. Automation, this is eliminating the manual tasks. Now, these are different ways in which the model could be deployed. The way you need to read the table is the column really represents the different ways in which the model could be deployed. Each row represents that for this each type of a model deployment, what are we using for a training perspective? How does a prediction happens? How the prediction results are delivered? What is the latency for prediction? And what is the system management difficulty? Right? So each row represents the values or the outcome of each model deployment against these parameters. Fair enough? The first one, which we call it as a REST API, and what we'll just see in the next slide is what exactly is a REST. Application programming interface is what we use for doing a deployment of a model. Now, in this case, what is assumed is that you already have made the model, and this model has been made based on the data set which is available as historical data, and that's why we're calling it as a batch. Okay, which means the train data which was used to build the model was available in a batch. What we do as a prediction is on the fly, which means the moment I enter the input, I'm able to get the output as a predicted value. And this is what we will see today. When I enter the input using the HTML user interface, we'll be able to see the output as a predicted output. The prediction results delivery, this again happens through a REST API. Latency for prediction, which means how much delay is there from the time when I take the user input to the time when I get the output back is so-so. System management difficulty is also so-so. When we move on to different patterns, then I'll probably explain you why we say the system management difficulty is so-so. Pattern 2 of a model deployment is when you have the data set being used for training is a batch. Prediction also happens in a batch, which means it's not that the user interface or the user inputs I have collected and I'm able to get the output immediately. In this case, there is a database which is created, which means I keep entering the input. So let's just go back to the loan application example. Let's assume there are 50 customers who have walked in today and they wanted to apply for a loan, right? So there are 50 applications which a bank has for a day. Bank will keep entering the details of the values or the parameters that are available in the application, and these features or these variables are stored in a DB. Now, what will happen is maybe the batch frequency which is defined, maybe at the end of a day, maybe the next day, maybe in middle of the day, all these input records which are available in a shared DB. And why we call it a shared DB? Because it's the same data set structure which has been used for training the model is where we are actually keeping the new records which come in. And through this DB, this DB is these new records which have been entered in the DB are given as an input to the model which is available, and the output which you get is again stored in the DB. So that's why we call it as a batch. Okay, I'll just repeat it one more time. So you have the data set which is available as a historical data, the normal data set or a CSV file which you have seen it. For a prediction or for the new entries which are happening, they are again stored in kind of a .csv file. Right? They are again stored as a data set. Now these records which have been stored as the new records which are yet to be predicted are given as an input to the training set, and what you get as an output is the prediction value. These predicted values are again stored back in the data set, which you can go and refer it. So let's assume there are 50 applications which have come in. These 50 or a batch of these 50 application inputs would be given to the model. The output would be again stored back in the data set or in the database or in a CSV file, and which will say record number 1. So for Anjana, the loan is rejected. For Ritesh, loan is approved, something like that, right? So that's why we call it as a batch. It happens through the shared DB. Latency for prediction is very high because this is a batch processing, right? So it's not that you're able to immediately see the result. Based on the frequency you define it for a batch execution is what it takes. System management difficulty is easy because you have everything available in a offline kind of an environment, right? You have the model which is available as an offline. You have the data set which is getting created from a prediction perspective is also kind of an offline. So it's the easy one. Pattern 3 is a streaming. Okay, and what is a streaming? In this case, what we are trying to do is we are actually making a change in the model when a new data set comes in. So let's assume, and this is the streaming is a platform which is used by all the e-commerce or a marketing kind of an industry. What they really do is, let's assume there is a model which was created on the data set which was available till yesterday, right? The new records which come in, the new records will predict based on the model which was created as of yesterday, but these new records will immediately become part of the trained data set, which means now the value which I have predicted, right, is what will be used as a given value, and even the model building is getting changed every time, right? So you have the training being done as a streaming, the prediction being done as a streaming. Latency obviously is very low. It's a very difficult environment to manage because normally what we have is we have a the architecture or the hardware which is available on which the model has been built. We have a separate hardware or a separate set of environment which is available on which we deploy the model. Now herein, because the new record which have come in as a stream is again being used for training the model, you have to be absolutely clear in terms of how the environment has been managed. Okay, so this is the most difficult. Now if you go back, as I said, when you are doing an interface through an API, the system management difficulty is so because in this case, the hardware which is being used, there is no separate, if I can use a word, a demarcation of saying that this is the separate environment which has been available from a training perspective or from a model building, and this is a separate environment from a prediction perspective. Pattern 4, which is more used for our mobile applications. Again, the training is streaming, the prediction happen on the fly. This is using an API on the mobile. Latency is low, and the system management difficulty is so. Okay. So what is the REST? This is a representational state transfer API, which is an API, as I said, is an application programming interface, which is used to integrate the user input which you are taking with the available enterprise application. On-demand analysis by GUI, which is a drag and drop prediction interface, which allows user to get prediction when they need them. Okay, this is whenever you want it. It's like giving a input now, and that's what we'll do. We'll enter the values on an HTML pages. Whenever we enter the values, we just press the submit and we'll get the prediction out. Scoring code export, which is model is available as an executable jar file or as a Java source code and can be deployed anywhere where Java, right? Something on the similar lines is what we'll be using on a Flask environment. So the key requirement for a model to be able to execute without the necessary support of the libraries, the one which we have used in the Python is to ensure that I bundle the libraries in such a way that machine is able to understand, right? And this is what we call it as an object file. So once you have created something, which a machine can understand, then you don't require those supporting libraries because they are bundled along with the object which has been. Okay. Standalone scoring engine, which is a separate staging and a production environment so that the model can be tested and implemented in a stable, isolated way. Some more deployment options which we have is a cloud deployment and a big data environment. Cloud deployment, as I said, it has become almost a necessity now, looking at the scalability which you require from for an organization and the way the hardware is changing. People, they do not really want to invest on this as an asset, and hence they buy the cloud. They have the space available in a cloud, and nowadays the industry has also provided you a platform which is available as a service. Okay. So when I'm talking about, and that's what I'll probably touch when we move on to the next one. So when I'm talking about Heroku as a platform, this is nothing but a platform which is available as a service on a cloud environment. Okay. Now, when I was talking about the clouds, there are multiple options which are available for an organization to get into a cloud deployment. One is you have your own private cloud which is available, right? Private cloud means this is a cloud which has the security restricted to an organization. And on that private cloud, you can have a platform which is available, right? And then you deploy it. The second option is, as I said, the organizations have already created a platform. So Heroku is such kind of a platform. So Heroku as a platform is available as a PaaS, which is platform as a service, PaaS. So what you need to do is, this is a free environment. You can create your own login and you can use this environment to do a model deployment. There are paid versions of Heroku which is also available. The free version has certain restrictions in terms of number of users who can provide a user interface, or number of users who can access the application, number of applications which you can deploy. But if you are looking at a demo kind of an application, if you are looking for a small project to be deployed, you can use these platforms as a service, right? So from a cloud deployment, you have an option of buying a cloud, creating your own environment, or you have an option of using the service as a platform which is available on the cloud. And that's what we'll use as a Heroku. Okay. So two things which we'll do. One is we will look at a Flask deployment and we will look at a Heroku deployment. The case study, as I said, this is a case study which I would be using it. This is to predict the salary. Just 2 minutes we'll spend on what the data set is. WHO is a specialized agency of the UN which is concerned with the world population health. Based upon the various parameters, WHO allocates budget for various areas to conduct various campaign initiatives to improve healthcare. Annual salary is an important variable which is considered to decide budget to be allocated for an area. Okay. Now this is the data which we have it. I'll quickly move on to the model which was created. I will not spend time in terms of discussing how the model was created. So what I've done is, for this data set, which has the variables like age, work class, sampling weight, education number of years, marital status, occupation, relationship, race, sex, capital gain, loss, working hours, native country, salary. I have created an HTML page to collect the user input for all the variables which are independent. So in this data set, all these variables are independent, and based on these variables, we are expected to predict the salary. Salary is available as a binary value which is less than equal to 50K or greater than 50K. The objective of this data set is, based on these independent variables, you are expected to predict whether the salary would be less than equal to 50K or it will be greater than 50K. So all these variables will work as an independent variable. This is a dependent variable. As the dependent variable class is binary, we are using logistic as one of the techniques. Okay. Now, assuming I have built the model. Okay. So the model is ready with me. Now, how do I go ahead and do the deployment using a Flask as an environment? What is Flask? Flask is a web framework that provides library to build lightweight web application in Python. Okay. This is based on WSGI toolkit. What is WSGI? WSGI stands for a Web Server Gateway Interface, which is a standard for Python web application development. And it is using Jinja 2 template engine. What is Jinja? Is a web template engine to render the dynamic web pages, right? What is a dynamic web page? Which allows you to take the input, and based on the input, the page gets rendered. What is rendering? Rendering means that the page gets processed. Okay. Flask requires 2.7 or higher version. Now, what are the steps for doing a deployment? The first step is you have to create a pickle of the model. What is a pickle? Now, if you remember in the last couple of slides back, I showed you that for a model to be deployed, we create a executable jar file, and that jar file we deploy in an environment. Okay? Similar to that executable jar file, what I am creating here is a pickle. Okay? In a very broad way, you can assume pickling is a process wherein the model which you have created, you are converting that into an object file. Why we are trying to do that? We are trying to do that so that I can use this file for the deployment. Okay. The file which you create has an extension as .pkl. The library or the package which you require in Python for creating a pickle is in pickle, right? So what I have done here is I can show you the code. We have imported the library pickle, and I am opening a file, right? I'm opening a blank file in a write mode, which I'm calling it as adult_flask.pkl. And then in this file, which I have created, I have dumped the model, right? This is the model which I have created, which is using a logistic. This is the file which I have created, right? So the model is dumped into this file. Now to find out whether the dumped file or the PKL file which I have created is working fine or not, I have loaded this PKL file and did a test on the test dataset to find out whether the model which I created is giving me the same result through a PKL file and through the model. Okay, I'll just repeat this step which I get. So the first thing which we do from a model deployment perspective is create a pickle file. What is a pickle file? A file which has an extension as .pkl, which is very similar to an object file which we created. How do I create a pickle file? We have to import the library pickle. If you already have not installed it, I'm sure you know it. You have to say pip install the file name. Create a blank file in a write mode. Ensure that the extension of the file is .pkl. And then the model which you have created, dump that model into the file which you have created. Once you have dumped the model, please check whether the PKL file is giving you the same result as the model. Once you're sure about it, then what you have is an adult_flask.pkl file available, which is nothing but a model ready for a deployment. Okay, so this is what is step number 1. What is the step number 2? You have to create a user interface file for getting the user inputs or for looking into the unseen data set, right? Now, as I told you, there are multiple ways in which you can create it. You can have a Java application being developed. You can use a .NET environment. You can use any other application front end which is available for the enterprise-wide application like SAP as an ERP. Or you can use an HTML editor to create the HTML pages. Now, there are a lot of options which are available for creating an HTML pages. You can use the CSS for doing a style sheets and all. I have created very simple HTML pages using Notepad as an editor. Okay, so this is the file which I have created as an HTML file. I have used Notepad as an editor. The objective was just to ensure that I'm able to get the user input. That is the reason I've just created a very simple file. Now, this is the way the HTML file looks like. People who are comfortable with the HTML, they would be able to look into it. Otherwise, I'll just explain it to you. You have broad divisions of an HTML file. The first is a header. The second is the user input which you're trying to take it, right? Now, these options are available for a drop-down kind of a list. So there are multiple ways in which you can take an input. You can allow user to enter the input, or you can allow user to select from the available inputs. Another file which I have created, although it was not mandatory, is a result file. Okay, I can have the prediction result being displayed on the same HTML file, but I have intentionally created a separate file as a result file just to show you that you can have a separate file as a result file, because normally in an organization you do not get to see the result on the same page, right? Otherwise there was no restriction. I could just add this part of the code, which is an HTML code, onto the same input file which I have created. Okay, so the step number 2 is create a user interface. Herein I've said create an HTML page because I am using the HTML page as a user interface, right? Okay. Step number 3, create a file with an extension .py using Python editor like Jupyter Notebook. Now, what I have created here is a file which is known as app.py. This is the main file which is being looked by the Flask. Okay, let's look at it, what the file has. These are two standard libraries which I have seen, NumPy, Pandas. I am using a Flask, right? This is a Flask as a package which I have loaded using a pip. Once it is loaded, I'm using it. So I'm using a Flask and I'm using a request render template. Okay. Now, what is request render template? These two are used by the HTML pages, right? I'm sure you would have seen I'm using the word rendering. Rendering actually means processing the HTML page which you have. The first line which you write here is an app, right? So app is equal to Flask. This is here you are initializing the Flask. Okay. The second part of the text is, I'll probably explain it through here. Okay. These are the libraries you have it. This is where you initialize the Flask. The next part is you define from where you are getting the user input, right? Herein I am getting the input through a file which I have created as an HTML, which is adult.html. The fourth block of the code is talking about the model which you have created. Okay, and herein I am using adult flask.pkl. This is the file which I have created using a pickle library, and this is what I define it, which we call it as a prediction function, which means those user input which I am getting from where they will be processed. The next part which I am giving is a output page. Okay. Now, if this was not a separate page, I would have given the block or the portion which was available in the first HTML file, but because I have created a separate page as a result, and that's what I'm mentioning. Okay. This is the main function of a .py file, and this is from where the program really starts. Okay. This is the first function which gets executed by the Flask. Now let's just go back and look at this one more time. So these are the libraries. This is where I'm initializing the Flask. This is where I'm giving an input, which is a .html file. This is the .pkl file of the model. This is the output part of it. And this is the main function which will get executed whenever I will initiate whenever I execute this app.py. Okay. So 3-step process for doing a deployment. Let's just quickly go back and look at it one more time. Step 1, create a pickle file. Step 2, create a user interface. Step 3, create a file by the extension .py. And this is what the format of the file should be. Okay. Now, you have to be very careful when you are creating a structure. What I have done here is I have created a folder by the name Flask. I'll just show it to you. Okay, this is the folder which I have by the name Flask. Under that, I have created another directory by the name templates, right, which has these 2 HTML files. So the main folder which I have is a Flask. Under that, I have another subfolder by the name templates, which has adult HTML and result HTML. At the same level, where I've created a templates, I have these 2 files being stored: adult_flask.pkl and app.py. Okay, this is the model file which I have it, and this is the .py file which I created. You just go back and look at it. I have adult_flask.pkl and app.py. Okay, this is mandatory that you should have a structure like this. Now, to execute this file, what we'll do is we'll go on to the Anaconda prompt. Herein I am at the Anaconda prompt. I will go to the library. I'll go to the directory which I have created. So I'm saying cd:/gl class. I reach the Flask. Once I am at the directory from where I have to execute the file, I'll say python app.py. Okay. Once I say python app.py, this is a lazy loading. Lazy loading means in the software industry or in the web pages, whenever you see a lazy loading means these are not loaded automatically. Whenever you request for it, it loads it. So this command will take another couple of 2-3 minutes, and then it will show you a URL, which is this URL. This is a URL for running the app on a local host. What is a local host? Which means running it on your machine. So once you do python app.py, you copy this URL, go back, paste it here, and what you get is a form. Okay. Now this is the input HTML form which I have created. Let me just enter some values. So let's assume age is, let me enter age as 40 years. Working class is, these are the drop down options which are available. Let me say local. Education is 12th standard. Marital status is married. Occupation is, let's say, a craft repair. Relationship is other relative. Race, gender as a female. Capital gain, let's assume I entered some value 999. Capital loss 88. Hours per week, let's say 40. Native country, let's say Canada, and I say submit. Now what it is doing, it is executing the model, doing a processing, and it will take me to the second page, which is a result page, when it will show me an output of a prediction which says income less than 50K. Okay, so this is how I deploy a model using Flask, and I'm able to get a URL which I'm able to run on my local machine. Now, I'm sure you would have figured out that this is a URL which I have created, which I'm able to run only on my local machine. So if I have to give this out to multiple users, if I have to give this out to multiple people, then it is not feasible, right? Unless I share my desktop and things like that. But practically, it is not feasible. So what we will do now is So this Flask as a deployment is good enough, and I have created some model, and I want to show this as a demo, or I want to just test this as a model. How will it look like when it will actually get deployed? Flask is a good environment to work on.
This brings us to the end of this tutorial on model deployment using Flask. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called as Create Learning Academy, where you have access to multiple free courses and you can get a certificate of completion once you complete them. So have a great learning ahead. Thank you.